Hi, everyone. So I'm going to be going over section 2.3 with you guys today. This is going to be lesson 4, and we're going to be talking about word problems. So you'll need something to write with and something to write on. Now, word problems in general can be a little tricky for students just because every word problem that you come across can be a little different from the one that you did before. But there are some key terms and phrases that we can look out for that'll make dealing with these word problems a little bit easier. And the best way to get good at word problems is to just keep practicing. So let's go ahead and write this down in our notes, unless you're using the guided notes that I've provided. So, one key strategy that you're going to want to use when dealing with word problems is to divide and conquer. Break the statement up into smaller pieces and then translate those smaller pieces. You also want to identify the key words and phrases, and a few words and phrases to keep in mind for this section. Of course, this isn't all of the words and phrases that we could come up across in problems, but these are a few good ones. Um, Here are some words: is, are, was, were, and makes up. That means equals. So that's what we're going to write in our notes, that all of these key words and phrases, this would translate into the equal sign. So if I said, you know, uh, Colleen is, X years old, is would be the equal sign. Sum, greater than, combine, and total. Hopefully, you know a lot of these words. This is going to translate into the plus operation, the addition operation. Words and phrases such as difference, less than, and minus, that would translate into subtraction. Of, increased by a factor of. Double and triple, this would translate into multiplication. And if you weren't sure, double means times 2, and triple means times 3. So you may also want to add that to your notes. And then quotient, divided by, half, and shared. All of these words and phrases are going to translate into division. And then half actually translates into divided by 2. So just a few things to keep in mind. You may want to have these words and phrases, next to you as you do all of these problems that we're going to go over today. Okay, so in general, this is how I teach my students to handle word problems. Again, your teacher might have a different way in which they want you to go about answering word problems, but I kind of have a system to the way that I teach my kids how to do word problems. The first thing that I always tell them to do is to define a variable. This is where you're telling me X equals and then some sort of word or sentence. The variable in your word problem is going to be the value that we don't know, and it's usually the question that's being asked. You may want to actually add this to your notes after you write this down, unless you're using the guided notes. You may just want to add it underneath where it says this, that the variable is usually the question being asked. Not always, but usually. That's how you can find out what your variable is. The next thing that you're going to do is you're going to write and solve an equation that uses your variable. Okay, so if you're saying that x equals, number of weeks, you don't want to change your variable into a different variable when you're writing your equation. You want to use that same variable that you defined. And then the last thing that I have my students do is to write their answer in words. And again, not all teachers are going to make you do this, but this is how I teach it. Okay, well, let's take a look at a word problem. So, a lot of times when I do word problems, I'll first read through the problem and then I'll reread it again. So, that's a really important strategy, that when you're doing these word problems, if you don't quite know how to set up your equation at first, read the problem multiple times. So, it says Jose bought 10 posters. Okay, so that's key information. I'm going to underline that because they're giving me a number. It says that he bought 10 posters. And then it says a week later, half of all of his posters were destroyed in a fire. Half, again, that's dividing by 2, right? We're dividing something by 2, or if you wrote it as a fraction, we can write it like that, right? We should all know that half means 1/2. So this is important information that they're giving me as well. So I'm going to underline that as well. There are now only 16 posters left. Again, they're giving me a value, they're giving me a number, so that's important. So I'm going to underline that. And then here's the question. It says, with how many did he start? So step 1, define a variable. It doesn't matter what variable you choose. I'm just going to choose x. And we have to state what x is equal to. Now, I don't know the value for x yet. I can't just say x equals 5 or x equals 2. When I say define a variable, I'm talking about this question here. And I did say that it's often the question that tells us what our variable is. It says, with how many did he start? Well, how many, we're referring to the number of posters. So how many posters did he start with? That's our variable. That's what we're trying to find. So I'm going to say that x is the number of posters Jose started with. This is how you define a variable. You're writing it as a few words or a sentence. It's the thing that you're looking for in the word problem. Now, this is a multi-step word problem. There's multiple things happening here. I often like to kind of write things in the order in which I see it, and oftentimes the order in which things happened in the word problem will kind of give you hints on how to actually write that word problem as an equation. So the first thing it's telling us is that Jose bought 10 posters. Well, if we know that he started with X, some mystery number of posters that he started with, I'm going to start with my variable X, because that's what he started with. And then it says that he bought 10 posters. That's 10 additional posters that we can add to the number of posters he has. So the way I'm going to represent that is I'm going to take my X and I'm going to add 10 to it. So this is the number he started with, and then he bought 10 more. Okay, so that's kind of what my equation is looking like so far. Then it says a week later, half of all of his posters were destroyed in a fire. Well, if I think about it, at this point, since he started with X and then gained 10 more, all of this is all of his posters. The X plus 10 is all the posters that he currently owns. So I want to show that half of all of this was destroyed. And as I mentioned, when we do half of something, mathematically speaking, we're dividing it by 2. But we're not just dividing the x by 2, and we're not just dividing the 10 by 2, we're dividing all of it by 2 because it was his entire collection that got cut in half. Okay, so this is now what my equation's looking like. And at this point, if this is the half that got destroyed, 2 halves are equal, so this should also represent the half that he also has left. They mean the same thing. Remember, if you have half of something, half implies that both halves are equal. So if this is the half that he also has left, and we're told that he only has 16 posters left, well, this has to be equal to the 16 that he has left. So now this is the equation that I'm working with, and I want to solve it using inverse operations. Now, one strategy that I taught my class is that if you have an equation that looks like this, and it kind of looks like a giant fraction, the first thing that you want to do is get rid of this denominator. In order to get rid of it, we undo this division here by multiplying by that denominator. The 2's are going to cancel, and I'm left with x plus 10. What I do to one side, I do to the other. I'm going to get 32. And now it's a one step. I undo this positive constant by subtracting it from both sides, and I get that x is equal to 22. Now, the last thing that we need to do is write this in words. If you're ever unsure on how to write it in words, go back to how we defined our variable. We said that x was the number of posters Jose started with. So I can put that together with the answer that I just got. Jose started with 22 posters. So that's what I'm going to write as my final answer. Jose started with 22 posters. And that's it. So go ahead and make sure that you have all of this down in your notebook. And then when you're ready, go ahead and give this one a try on your own. I'm going to pause the video, and then when we both unpause, you should see a solution here. Okay, so here is the answer that you should have gotten for this one. Whoops, I lost part of my definition. Let me fix that as I was erasing part of my problem. There we go. Okay, so you should have defined in some way, shape, or form that your variable was Asanji's weekly allowance, and then the equation that you should have gotten should have looked like this. So notice it looks a little different from the one before, and I did mention that oftentimes the order in which events are happening can sometimes dictate how you write your equation. So in this case, it says that Asanji first spent half of his weekly allowance. So the first thing that's happening is we're taking that weekly allowance, which is our variable, and we're dividing it by 2. Then he earned more money. So that's going to be addition. More means add. And the addition would be with 8 because that's how much money he got. So we're not adding the 8 with the x in the numerator and making it look like a giant fraction. That plus 8 happened after. So it's going to be separate. So it's just going to be a normal two-step equation where we undo the constant first by subtracting, and then we undo the division last by multiplying, and you should have gotten x is equal to 10. Last but not least, you should have written in words something along the lines of his weekly allowance is $10. Okay, let's take a look at another one. It says Aiden borrows a book from a public library. He read a few pages on day 1. We don't know how many pages, but it says that he read a few on day 1. And then on day 2, he reads twice the number of pages than he read on day 1. My lines are coming out a little crooked. Okay, so twice, remember that means times 2. That was one of those key words on that first page. And on the third day, he reads 6 pages less than what he read on the first day. Can't seem to draw my lines very straight using this Wacom tablet. Okay, so less than is a very interesting subtraction phrase. Less than does mean subtract, but you're also going to switch the order. Okay, so I might make a little note over here. Less than flips the order. So it says 6 less than what he read on the first day. So what we're going to do is take the amount he read on the first day, put that amount first, and then subtract 6. If he has read the entire book that contains 458 pages, how many pages did he read on day 1? Okay, well, first let's identify the question that's being asked. That's our question, right? How many pages did he read on day 1? Well, that's my variable x. I'm going to say x is the number of pages Aiden read on day 1. Okay, and we're told he read a few pages on day 1. Well, we just said that the number of pages he read on day 1 is x. So on day 1, he read x many pages. On day 2, he read twice the number of pages he read on day 1. Well, twice means times 2, and I'm doing 2 times the amount he read on day 1, which is x. So at the very end, in order to get all of the pages he read, we're going to add all the pages that he read on each and every day. So he read X pages on day 1. He read 2 times X pages on day 2. And to get the number of pages he read across both of those days, we would add these 2 expressions together. And of course, to get the total number of pages he read, which is the 458, we would have to add how many pages he read on the third day. Well, let's see what he read on the third day. So I'm going to go back and reread it. It says that he read 6 pages less than what he read on the first day. Well, he read X pages on the first day, and 6 less than that would mean I'm subtracting 6 from it. So notice how I'm writing it. I'm not doing 6 minus X. I have to do X minus 6 because, again, that phrase less than, it flips the order. So the 6 should actually come after my subtraction symbol, and the amount he read on the first day, which is X, should go before. So here's the entire sum of all the pages he read across all 3 days, and if I add that all up, it should equal the number of pages he read in total, which we were told was 458. I now have a multi-step equation, so I'm going to go through my checklist where I look for parentheses to see if I have to distribute. I don't have parentheses, so the next step is to combine like terms. I have a few x terms that I can combine. X is really just a 1x, and if I add those x terms up, I get a total of 4x. 2 plus 1 plus 2 is 3. 3 plus 1 gives me 4. And then the minus 6 equals 458. Whoops. Just comes down for the ride. And now at this point, it's a two-step. I'm going to undo this negative constant first by adding it. 4x comes down for the ride. Let's see, 6 plus 8, that's going to give me 14. And then carry the 1. 5 plus 1 gives me 6. And then bring the 4 down, and these two values are equal. And then the last thing I need to do is I need to divide both sides by 4 to get the x by itself. I'm going to have to write my final answer off to the side here. And I'm also going to have to do a little work off to the side here. I have to divide 464 by 4. So I'm going to attempt to do that a little small off in this corner here. Hopefully it's not too small for you to see. 4 goes into 4 one time with no remainder, but I have to bring this 6 down and keep going. 4 goes into 6 one time with 2 remaining, bring down that 4, and I have to keep going. 24 divided by 4 will give me 6, evenly with no remainder. So my quotient when I divide here is going to give me 116. That's a lot of pages to read on one day. And then the last thing I need to do is state my answer in words. So Aiden read 116 pages on day 1. Okay, so make sure that you have all of this in your notes, and then I'm going to pause the video and give you the next one to try. So here's the next one. Oh, actually, I lied. I'm going to do one more with you, and then I'm going to give you one to try. So we're going to do one more of those more complicated multi-step equations. So it says in the 2006 Winter Olympics, Sweden won 3 medals more than China. So more than means we're adding 3 to however much China won. We don't know how many Olympics they've won yet. We have to keep reading to see. Germany secured 1 more than twice the number of medals. This is really crooked. 1 more than twice the number of medals bagged by Sweden. So we're doing a couple things here. We're taking the amount that Sweden won, and we're adding 1 to twice the number that Sweden won. So this is a little complicated. So we're doing, we're adding 1 and then times 2 to the amount that Sweden won. So what we're going to have to do here is write an expression that represents how many medals Sweden won, multiply that entire expression by 2, and then add 1 to it to represent how many Germany won. If 54 medals were won in all, okay, so they're giving us the total. So if I added up the amount that Sweden, China, and Germany all won, and I added them all up, that would equal 54. Then how many medals did China secure? So here's the question. How many medals did China secure? Oftentimes, the question that's being asked is how we're going to define our variable. So I'm just going to use x again. Again, it doesn't matter which variable you choose, so long as you're defining it and using it. I'm going to say that x is the number of metals secured by China or won by China. And if this one's a little confusing, it might be better to kind of break it down by country first to see what we're dealing with. So we know that China won X many medals, right? Then it tells us that for Sweden, they won 3 more medals than China. Well, China won X, so if I take X and add 3, that's how many medals Sweden won. And then Germany, we're told that they won 1 more than twice the number of medals bagged by Sweden. So what I need to do is I need to take the entire expression that Sweden, that I have here for Sweden, and I need to first multiply it by 2. In order to do that for the entire expression, I need to enclose it in parentheses because this entire expression is getting multiplied by 2. And then I want to do one more than that. So I'm going to add 1 to this entire thing. It might be helpful if I did it in different colors. So here, let me try and do that real quick. Can I select just this little bit? Nope, it's going to select the whole thing. So let me actually just show you that the thing that I'm writing in red first is what happened first. I need to take this expression, put it in parentheses, and do times 2. And then I'm adding this 1 at the very end, okay? You can also think of this word again, than. That word than is going to flip the order. That being said, addition, it doesn't matter the order in which I write it. I could have done 1 plus and then this expression, but the important thing is that the 1 is on the outside of the parentheses and that the 2 is touching a set of parentheses with Sweden's expression sitting inside. And then we're told that 54 medals were won in all. So I need to add all of these expressions to get how many medals were won in all. So here's what it's going to look like. I'm going to take China's expression, which is X, add it to Sweden's expression, which was X plus 3, and add this to Germany's entire expression, which was 2 parentheses X plus 3, close parentheses, plus 1. So here's my entire algebraic expression for my equation, and this has to equal 54 since that's the total number of metals. So quite a complicated looking expression, but again, if you take your time and you break it down in steps, it's not too bad. So first step, when we have a multi-step equation, I need to distribute first. I'm distributing a positive 2. I'm going to bring down everything else. And then when I distribute, I multiply. 2 times x gives me 2x. 2 times 3 gives me 6. I bring down my plus 1 equals 54. And I have quite a number of like terms that I now need to combine. I have these x terms. Again, this is 1x plus 1x, which gives me 2x. 2x plus 2x gives me 4x. I have these constants. 3 plus 6 gives me 9. 9 plus 1 gives me 10. And now that I've done all of that, I now have a 2-step that I can solve. I'm going to undo my positive constant by subtracting, bringing down my 4x equals 44 is my difference. I have to undo this coefficient by dividing, and I can do this one in my head. I get x equals 11. And again, this is the number of medals that was won by China. So the last thing I want to do is state my answers in words. So if China won this many medals, I can say China won 11 medals. And here's the entire problem done in its entirety. So now I will give you one to try on your own, but make sure that you have all of this in your notes first. Okay, so here's one for you to try. I'll pause the video, and when we unpause, you'll see a solution. Okay, so here's what you should have gotten for this one. So it says that the lifespan of a guinea pig is 6 years less than that of a giraffe. So again, less than, you're going to flip the order of the terms. You're going to take the lifespan of a giraffe and write that value first, and then subtract 6 from it. The lifespan of a tiger is 4 times that of the guinea pig. If the total lifespan of the animals, so total means we're going to add everything up, if the total of the animals is 30 years, so that means equals 30. It says calculate the longevity, or in other words, the lifespan for the giraffe. So in this particular word problem, they're not explicitly asking a question, but they are directly telling you what it is you should be solving for. And what they're telling you to solve for is your variable. So the longevity or lifespan of the giraffe, that's what your variable should have equaled. And then what I did is kind of similar to the previous question, where I wrote expressions for each thing first. So X is my giraffe. The guinea pig is X minus 6, since the giraffe is X. And then the tiger is 4 times that of the guinea pig. So similar to the last problem, 4 times the guinea pig, I want to take that entire expression for the guinea pig and close it in parentheses and do 4 times that entire expression. You got to make sure that you're using parentheses here. You don't want to just do 4 times x, and you don't want to just do 4 times 6. It's got to be this entire expression, which is why we need the parentheses. And then it says that the total is 30 years. So total means you're going to take all of these algebraic expressions and add them up. So the first expression is x plus the second expression was x minus 6 plus the third expression was 4 parentheses x minus 6. And this has to equal 30. Once you've got your equation, you want to distribute first, since we see parentheses. So I'm doing 4 times x, which is 4x, 4 times negative 6, which is negative 24. And then after that, I'm combining all of my like terms. 1x plus 1x is 2x, and then 2x plus 4x gave me the 6x. Negative 6 minus 24, their signs are the same, so I'm going to add them together and get 30 and match the negative sign for the things I added. And again, this equals 30. At this point, it's a two-step equation. I undo the constant first, which was negative, by adding 30 to both sides. I get 60 on the right. And then the last thing I do is divide to get rid of that coefficient. And I got x is equal to 10. So then I just wrote my sentence. A giraffe's lifespan is 10 years. Okay, let's try another one. I'll guide you through this one. It says, Martha takes her niece and nephew to a concert. She buys t-shirts and bumper stickers for them. The bumper stickers cost $1 each. Martha's niece wants 1 shirt, which we don't know the cost of yet, and 4 bumper stickers, which we know are $1 each. So if I was to get my total for how much Martha paid for these bumper stickers, I could just multiply. I could do 4 times the $1, and that would give me the total cost. And her nephew wants 2 shirts, but no bumper stickers, so we don't even need to worry about that part. If Martha's total is 67, so equals 67, and again, total means that you're adding what she paid for both the niece and the nephew together. What is the cost of 1 shirt? So that question is our variable. It's not always a question, but if you see a question at the end of the word problem, chances are that's your variable. So I'm going to say x is the cost of 1 shirt. So just as I was able to get the total cost for the bumper stickers by multiplying how many were purchased and the price for one, I can do the same thing with the shirts as well. 1 shirt, well, my total cost here would be 1 times the cost of 1 shirt, which we don't know, it's x. And same thing here for the nephew. He wants 2 shirts, so I would do 2 times X for how much was paid there. So the niece, again, you can break it down into pieces first. This is how much was paid for the niece. She had 1 shirt, so 1 times X, and so I'm gonna add 4 bumper stickers, so 4 times 1. For the nephew, he got 2 shirts, so 2 times X, and no bumper stickers, so plus 0, or I just simply don't write anything. And if I take both of these expressions and I total them up, in other words, I add them together, this has to equal the 67 that Martha paid. So I'm going to take 1x, or I can just write it as x. Remember, there's an invisible 1 there, plus 4 times 1, which I can just do right now. That's going to give me 4, plus what the nephew got, which is 2 times x, or just 2x. This has to equal 67. I don't see parentheses, so I don't have to distribute for this one, so I'm ready to just combine my like terms. 1x plus 2x gives me 3x, and then I bring that plus 4 down for the ride. And at this point, it's a two-step. I undo my positive constant by subtracting first from both sides. 67 minus 4 gives me 63, and then I undo that multiplication, which is what is implied here when a number touches a variable, by dividing. And I can actually do this in my head because both of these digits are easily divisible by 3. 6 divided by 3 gives me 2. 3 divided by 3 gives me 1. So there's my answer. And last but not least, I stated in words. What is the cost of 1 shirt? 1 shirt costs $21. Okay, and here is one for you to try. So I'm going to pause the video again and go ahead and give this one a try on your own. Okay, so here's what you should have gotten for this last problem. So it says Noah and Kate are shopping for new guitar strings in a music store. Noah buys 2 packs of strings. So again, if we want to find that total cost, we can do 2 times whatever it costs to buy 1 pack of strings. Kate buys 2 packs of strings, and so we're going to add an additional cost, a music book, which we're told is $16, so plus 16. Their total cost, so total means I'm adding up everything, is 72, so it equals 72. How much is 1 pack of strings? So that's what I define my variable as. X equals the cost of 1 pack of strings. And I kind of broke it down like the other problems where I did an expression for Noah. He bought 2 packs of strings, so 2 times X, which is the cost of 1 pack. And then Kate bought 2 packs of strings also, plus the $16 music book. So if I add both of these expressions up, 2x plus 2x plus 16, this is $72, so equals 72. There's no parentheses, so I don't need to distribute, and I can just combine my x terms, which gives me 4x. And at this point, it's a two-step. Undo the positive 16 by subtracting, undo the coefficient by dividing, and I did my long division off to the side here. I got x equals 14. So last but not least, I stated it in words. 1 pack of strings costs $14. I hope that you guys found this video helpful, and good luck with your problems.